an AWS advanced technology partner with data and analytics competency. And they offer a database proxy solution, a smart database proxy solution. We have been working with Heimdall data in the recent past, and we really like their solution for the connection pooling and read-write split in particular, along with many other capabilities that they offer in terms of SQL caching and failover and so on for Amazon Aurora and RDS. And that is where we thought it will be super helpful for everybody to come out and attend this session and learn directly from Heimdall data guys, Roland and Eric. We'll be taking some deep dive on how it works and architecture overview.
And our webinar agenda will be the following. I'm going to be giving a database proxy introduction, and then we're going to dive straight into a hands-on demo led by Eric. We're going to be demonstrating automated query caching, read-write splitting, connection pooling and multiplexing, and we're going to end the remainder of this session and dedicate it for Q&A. Why don't we get started? Heimdall Data is an advanced technology partner, competency in data analytics, and we're a database proxy. Some people call us or describe us as a SQL traffic manager. And very simply, we improve SQL read-write performance and reliability. The third bullet is the most notable and differentiating. Deployment of our proxy requires no application changes. And the goal here is that for application owners to leverage the RDS scalability and performance really relies on the application to efficiently interface with Amazon RDS. And that's where there can be a lot of inefficiencies. And we help application owners, application developers, and even DBAs improve read-write performance and reliability without code changes. Now you may ask how we can work, how can a database be deployed without any application changes? In this slide, it shows two software options. The first one on the left, we run as an agent, as a separate process that can be installed on the application EC2 instance or as a separate database proxy tier. And you would use our Postgres, MySQL, or SQL Server proxy. The other software option that we have is that we are packaged as a JDBC driver, by which you would shim in or install our jar file in between the application and your current vendor JDBC. In either of these packages is just a connection change, whereby the application would connect to our proxy via networking, IP and port, or with the JDBC driver, you're just changing the class path, the URL. So it's a one-line change. After that, there's no other application changes that need to be made. All features are based on our console, and it's all policy-driven on our GUI. Quite simple. In this slide here, I'm just going to briefly go over the many features that we can support for the application owner. We have the application up here, and it's going to go through our platform, and it's going to hit the various Amazon services, whether it be Aurora, RDS, Redshift, and even Amazon Athena. Okay. We support, what we're going to talk about today is the row on the top, which is automated SQL caching or query caching. What we do is we can automatically cache and invalidate query results to the cache of your choice. So just to be very clear, we're providing the caching logic. We don't provide the cache. You point Heimdall data to the cache of your choice, whether it be Elasticache, Redis, Hazelcast, what have you, or even local memory. And we'll put the queries in there in an intelligent and efficient manner such that you're going to get a performance benefit. And most notably, we do the auto invalidation as well. We're also going to demonstrate read-write splitting as well, or read-write splits, whereby we are SQL aware, and we're going to route the writes to the writes and the reads to the reads. And then lastly, we're going to demonstrate connection multiplexing and connection pooling. There are some other features as well that we support, but we're not going to get into those today. But if you have questions around those, we'll be happy to answer them in our question and answers session. Now, in terms of deployment, you can run again as a database EC2 proxy tier, where all the applications would go through our proxy. We'll perform a bunch of features, as mentioned, SQL caching, read-write splitting, connection pooling, on behalf of the application to the database. So Heimdall actually consists of two components, quite simple. It's the proxy, and you can have as many proxies as you want, and it's all being controlled by the Heimdall Central Console. Both of these are available for download at the AWS Marketplace. So that was centralized mode, and this is distributed mode. This is the second way to deploy us. Instead of having a centralized or central proxy tier, you can deploy our proxy on each application EC2 instance. This is the most scalable and the most performant way of deploying our proxy. So you have centralized and distributed. Here are a couple of customer use cases and success stories. And I won't go into detail with all of them, but basically their challenge was a need to offload SQL performance, or there was a database overload, and it was just too costly for them to change their application or to develop a caching solution. So with Heimdall data, within one click, they were able to create and have a cache subsystem whereby they could cache their SQL results and then do invalidation into Elasticache. Some of the benefits that they had were they saved 4 developer resources. They installed and had a caching solution in 1 day versus a year and a half of development and testing and maintenance. Here with movie times, they increased their scalability 10 times, and they saved a couple of developer resources. So I'm going to go to the use cases in detail now for the next few minutes before I hand it off to Eric. Regarding caching, we have this two-tier architecture whereby we cache the hot objects in local memory in the EC2 application instance. And then we also leverage Elasticache as a level 2 cache and as a means of communication between the proxies. That way, all cache is current, and that when you're served results, the SQL results from cache, results are always fresh and never stale. Regarding read-write splits, as mentioned, we route queries to the designated write or read server. What's unique in our solution is we have lag detection, so that whenever there is a read from the read instance, from the RDS instance, you can be guaranteed fresh data. We have lag detection such that if there is a read, a read followed by a write, there may be some synchronization delays. And if the read happens within that lag window, we will go to the write instance or the write master to retrieve the data to guarantee that the data is fresh. As mentioned, whether it be caching, read-write splitting, or connection pooling, or whatever feature that we may have, it requires 0 application changes. And I'm going to stop right here and turn it over to Eric to begin our demo.
What I have on my screen is a web browser that's open into our central manager. I have 3 applications loaded and set up that I'm going to be demonstrating. The first one of which is Udo, which I have a traffic generator passing traffic on. And at the moment, I don't have any of our features really active on this, at least not caching or read-write split. And you can see that we're getting about 900 queries per second under this traffic generator and this load. Now, the first thing that I'm going to do is I'm going to come over to the rules, and what we have are a variety of rules, and one of them is this cache rule here, rule number 2. Now, the first thing I'm going to do is I'm going to enable that. We're going to come over here, and then we're going to look at the dashboard. Now, nothing happened. Now, you'd say, Eric, you just enabled caching, but I don't see any cache hits happening. Why not? In order to answer that, let's actually go over to the analytics, and we're going to analyze this. Actually, let me select Udo, analyze. And what we're going to see here is that all these queries are in transactions. Now, Udo, because of the framework that it uses, 100% of all queries that it does are in transactions. If we go over to the rules here, what we notice is that this checkbox is unchecked for in trans or in transaction, which means this rule is not actually applying on any of those queries. And that's why we didn't get any cache hits. Now, I know that I can safely turn on this in trans flag, and it'll start caching fine. But I'm going to enable another one of our features, and that's what we call delayed transactions. What this does is it basically says, even if the application says to do a transaction, wait until a DML has occurred before actually starting the transaction. Now, this isn't going to work for 100% of applications, but it is something that can be useful in many environments, in particular when you've got a framework that always does transactions. So what I'm going to do is I'm going to enable that to be true. I'm going to go back over to the dashboard, and we're immediately going to see the impact of being able to start caching on this. Now, what we're going to see here is that the average query time went from about 2 milliseconds down to around 300, or it's approaching 300 milliseconds as the cache hit rate piles up. I'm going to pause this, and you can see that we're doing about 800 to 900 queries per second before, and we've gone up to 1,400 queries per second. And it would be higher, but this is a CPU-bound application primarily. But you can definitely see the impact on the query response time and the number of queries that are making it to the application itself. Okay? So that's just demonstration of caching and the benefits that you can get out of that. And again, it's as easy as enabling this one rule and telling it to do delayed transactions. I'm going to come back over here, and I'm going to do take a look at these analytics again as well. Another one of the features that's enabled by the rule is indicated by this little icon, which is the query plan extraction. I'm going to come over here, and I'm going to pop out the more information about this query. It tells you what tables are involved in the query, and it also shows you the query plan that was extracted from the database. This is again done via the rule here of extract plan, and by default, any query pattern will only be extracted once every hour, so that it's not going to add any significant load to your system. Okay. So now I'm going to go back over here, and I'm going to look at Magento for a moment. Now this is the Udo application. I'm going to click here to Magento, and I'm going to click in here. I'm going to look here. I'm going to click in jackets. I'm going to look at tanks. Okay, and at the same time, I'm going to come over here, and we're going to look at the queries that are coming through. So what we see here is that there are actually, any individual page view of Magento generates a lot of queries against the database. I'm going to come on over here, and I'm going to look at the Magento rules. And I can turn on caching, but I'm going to demonstrate the reader eligible, which is the read-write split functionality. In order to understand that, let's look over here on the data sources and look at the load balancing. What we have are actually two target URLs. One is writable, and the other one is readable, or is not writable. So what I want to do is I want to offload as much traffic onto this reader node as possible in order to reduce the load on this writer node. So let's go back to the dashboard. I'm going to unpause this. Okay, I'm going to do Magento only. Now I'm going to come back in here again, and I'm going to look at jackets, tees, Some of these queries end up being a little significant. Okay. Now, let's look over here at what actually happened. I'm going to pause this again. And what you can see is that the blue is the master, the queries, and the reader is this purple. So the vast majority of all the queries that made it to the database in this case were now sent to the reader instead of the writer. Now, if we look at this again, we've got a ratio of 1 to 10. So 1 out of 10 reads will still go to the master, but this demonstrates that you're able to automatically use the read-only replicant servers automatically, even in an application that does not support read-write split. Now, again, if we look at the rules here on how this works, we're setting this to support intrans. We could remove that so that if we're not in a transaction, we're not going to use that. That's generally what you're going to want to do, and that would be safe as well. We also have the logging here. This is set to only log 1 out of 100 queries. This is how you can kind of manage and control your log infrastructure and how much load it's going to have to deal with. But let's turn on caching. We've got the read-write split. Great. Let's go back over to the dashboard. Do Magento. Oh, let us unpause that. Okay. And again, just like before with Udo, we're able to get a good cache hit rate. If we generated a bunch more traffic, this actually would end up being about a 90% cache hit rate. Okay. For e-commerce applications, we actually see that about a 90% cache hit rate is actually very typical. As a final demonstration, just to demonstrate that it is working, I'm going to come over here. We're going to go, and this is a WordPress page. Again, I can come in here. I can enable the caching, and I can do the query plan extraction, commit, come over here, and we're immediately able to see cache hits, and very significant cache hits are happening. Okay. So I've demonstrated just in a very short period of time the cache capabilities. I've shown the analytics. I've shown read-write split. I've shown the delayed transactions. Within the data source configuration, we can do connection pooling. A very extensive set of connection pooling attributes in order to control how the connection pool works. If any of you are familiar, these will look very familiar. These are the settings that are available in the Tomcat connection pool, which we leverage underneath the hood as our own connection pool. Okay. Now, we have a couple of questions that have shown up in the chat. The latent question number 1 was dealing with the latency of the proxy. When you're dealing with caching, as a general rule, you're going to save more than it actually adds. However, it is an additional step in processing. So if you're not getting any cache hit rates, you're going to end up with a slightly higher, but generally trivial amount of latency. As Roland had mentioned, we have a distributed model where you can put the proxy actually on the same server as the application. So it doesn't even have to go across the wire in order to get to the proxy, and then it can cache the objects immediately in the same memory space as is on the server of the application. Alternatively, you can run it in a centralized mode where it's on its own central server. That's what we generally suggest to people to do as the initial trial, because it is much easier to set up and you don't have to worry about anything. But we are designed to operate as a fully distributed system. So all the nodes talk to each other and they share invalidation information. So when we see a write happen against the database, that information is shared to all the nodes such that they all will invalidate the appropriate objects at the appropriate time. Let me see what other questions there are. Within the connection pooling logic, we generally do round robin, but as I said, we're leveraging the Tomcat connection pool. So all the logic and configuration options that are available for the Tomcat pool are available within Heimdall. Next question, what is the agent footprint? If you exclude caching, which obviously is going to be something that you can control and configure, the memory footprint is less than 500 megabytes of memory. Okay. Next question, for connection pooling, how much memory does the proxy use per connection? It's actually a relatively trivial amount of memory. We are going to be working with one customer that's going to have several thousand connections terminating on Heimdall and then using the connection pool. But under testing, the per connection load is very, very minimal. Next question, are we a SaaS provider? We are not a SaaS provider. We do have an AWS marketplace image that you can spin within your own VPC, and you can operate it within your own infrastructure. How do we implement HA for the proxy? The proxy itself is designed to be a completely distributed system. If you're using us in distributed mode, then we would sit with the application. So you effectively would have a one-to-one mapping between the application nodes and the proxy nodes. So effectively, if the proxy fails, you'd want your front-end load balancer to be able to detect that. So it fails the node as a whole, not just Heimdall itself. Alternatively, you can set up several proxy nodes on their own servers in a centralized mode, and then use any form of load balancing you wish, including ELB within AWS. Next question, how much memory to support 30,000 connections? Honestly, it's not the connections that are going to be the issue, it's how much memory you want for caching. Okay, but even just a few gigabytes of memory would easily support 30,000 connections. Aside from the memory cache itself, we do have a layered approach for caching. Within each proxy node, we do store the hottest objects locally, and then we leverage systems like Elasticache to act as a backing store for either larger objects or less frequently used objects. Since we still have a little bit more time, just to give you a brief tour within Odoo, for example, this is how you configure your the proxy. You can set it to be a port. You can have it bind to a specific IP address, local IPs, whatever. For caching, we can come down. In this case, we're only using the local cache, but we can go into Redis and we can do different configurations there. Or we can do any one of these other systems that we support. Okay. And then for the rules, let's go back over here. We can also look, there are a lot of different functions that are available. We've only touched on the very top of the functionality. There's a lot that we support in depth. Okay, another question of what is the PCI HIPAA cache? In many environments, you don't necessarily want to send the cached objects over the wire. Because the cache connection itself may not be encrypted in order to improve latency characteristics. When you set the PCI HIPAA cache, it actually only caches the objects locally, but it synchronizes the invalidation of objects globally. That way, all the objects are kept in memory and are considered in flight. And then finally, on pricing, Roland, do you want to talk about the pricing?
Sure. As Eric mentioned, we are in AWS Marketplace, so it's a per hour charge per proxy. If you're interested in an annual subscription, you would download and purchase directly from Heimdall Data. And what an annual subscription gives you is unlimited usage of that proxy for any instance size. So we have per hour and per year pricing.
Any other questions?
Eric, did you want to go over multiplexing at all?
Okay. In the context of Postgres, actually, let's talk about the support functionality. Whoops, I want to go back here. Okay. When leveraging Postgres, one of the features that many people are looking for is a TG bouncer replacement, which does connection pooling and multiplexing for Postgres. Because of the memory model and threading model for Postgres, it's quite important that you reduce the number of connections as much as possible. What we have for specifically for Postgres, but we can actually leverage this for others, but the benefit is most important for Postgres, is multiplexing, where we are able to maintain a small pool of connections to the back end, and we effectively spray the queries across the back end in order to leverage or in order to utilize those connections fully. This allows you to use a much smaller number of connections for a given workload. Okay. Any other questions? Okay. Please feel free to visit our webpage on www.heimdalldata.com. Contact us for more information if you wish. And again, we are on the AWS Marketplace. We do provide free 30-day trials within the Marketplace. So if you want to try out Heimdall, download it from there, and let us know if you need any assistance. Okay.
All right.
Thank you.
Jatin, we can turn it over to you.
All right, thank you, everyone. In addition to the webinar, we are also doing a joint blog with Heimdall Data, which talks about the solution we just discussed. It's going to be hosted on the AWS partner webpage. Feel free to ask any questions directly to the email and contact which Heimdall has left out, or if you have any follow-up questions, feel free to reach out to us as well, as we are closely partnering with Heimdall Data.